In this question, we are given a shape called a Norman window. A Norman window will always be a rectangle with a semicircle on top of it. This Norman window has a width labeled W, a height labeled H, and a semicircle on top, and its length will be labeled S. Our first task is to write an equation for the perimeter in terms of H and W. This means we will need to eliminate S somehow. In order to eliminate the S, we must look at the relationship between this semicircle and the width below it. We must first realize that this semicircle has a diameter which is symbolized by this dotted line I've drawn. However, we know that diameter is the same as W because in a rectangle, the bottom side and the top side must be the same. That means we know that this dotted line has a length of W. Now let's think of equations that could give us the length of S. We might remember the circumference of a circle is equal to 2 pi r. However, we can also write this as pi times d, where d is the diameter. We don't have any letters to symbolize the radius, but we do have a letter to symbolize the diameter. That's W. However, we don't have a circle, we have a semicircle. Therefore, we can say that S for the semicircle is half of pi d. If a full circle is pi d, then a semicircle must be half of that. So we'll say that S is equal to 1/2 pi d. But since our diameter can be replaced with the letter W, we'll say that S is equal to 1/2 pi w. This means that as we write the perimeter, we can replace any occurrences of S with 1/2 pi w, and we don't have to use the letter S anymore. With that in mind, let's try to write an equation for the perimeter of this window. We can say that the perimeter will contain a W on the bottom, it will contain a height on the left, it will contain an S on top, and then it must contain another height on the right. If we combine these terms together, we'll get W plus 2H plus S. But now we can replace that occurrence of S with 1/2 pi w. Therefore, we can say perimeter is equal to W plus 2H plus 1/2 pi w. This will be our perimeter in terms of just W and H. Now that we have an equation for perimeter, we are asked if the perimeter is 24 feet, find an equation for H. Therefore, we must now solve for H. With our equation for a perimeter, we'll let H be our unknown we're going to try to solve for, and we'll move everything else away from that H. Our first move will be to subtract our W and move it to the left. If we subtract that W and move it left, we'll have P minus W equals 2H plus 1/2 pi w. Since we're still going for H, we can take the 1/2 pi w and move it as well the same way. We now have P minus W minus 1/2 pi w equals 2H. Then we can divide everything by 2. If we divide everything by 2, that's the same as multiplying all of the terms by 1/2. If we multiply everything by 1/2, we now have 1/2 P minus 1/2 W minus 1/4 pi w is equal to H. We now have an equation for H, but now let's use the fact that the perimeter is 24 feet. So we'll replace P with 24. This P that I'm boxing in green will become the number 24, and 1/2 times 24 will give us 12. Therefore, our height will be 12 minus 1/2 w minus 1/4 pi w is equal to h. This will be my equation for height. Therefore, now if I know the width, I can find the height, and vice versa. Part C of this question asks us to write an equation for the area of the window in terms of w. We'll have to make a note that the area of the window will equal the area of the rectangle plus the area of the semicircle. The area of a rectangle will be the length times the width. Inside of our rectangle, our length is h and our width is w. Therefore, we can say that the rectangle's area is h times w. The area of the semicircle is a little bit trickier. We know the area of a full circle is equal to pi r squared. However, we can also say the area of a circle is 1/4 pi d squared. This is the form of the equation you use if you know the diameter but not the radius. However, we don't have a circle, we have a semicircle instead. Because we have a semicircle, we're going to cut that in half again. So the area of the semicircle is 1/2 multiplied by that 1/4 pi d squared. If we multiply that out and simplify, 1/2 times 1/4 gives us 1/8 pi d squared. However, our diameter for this semicircle is just the width of the rectangle. Therefore, we can say that the area of the semicircle is 1/8 pi w squared. This will equal our total area. Now we have the equation in terms of h and w, but we were asked to get it just in terms of w, so we're going to have to make another substitution. However, in one of our previous steps, we found an equation for height. That was 1/2 the perimeter minus 1/2 w minus 1/4 pi w. We can place that trinomial in place of h. When we plug in that h, we'll have w times all three terms of that h. That is 1/2 p minus 1/2 w minus 1/4 pi w. Still, we'll have plus 1/8 pi w squared. Let's take that w on the outside of that parentheses and distribute it to all three terms that are inside. We'll take w times 1/2 p, and this gives us 1/2 pw. We'll take w times negative 1/2 w and get negative 1/2 w squared. Then we'll take w times negative 1/4 pi w and get negative 1/4 pi w squared. And then we'll add the extra 1/8 pi w squared. To simplify a little bit further, we can look at all the terms that have w squared and factor out w squared. When we factor it, we now have area equals 1/2 pw plus w squared times the parentheses. We'll pop the w squared out of each term that contains w squared. So first we'll have negative 1/2 minus 1/4 pi plus 1/8 pi. This will be our formula for the area of the shape simply in terms of w and perimeter. Now in part D, we're asked to find the maximum area for the window. Remember, if we see the word maximum, we want to think of the vertex. The vertex formula will tell us that x is equal to negative b over 2a. This time, instead of x, we'll be using w. So our w is negative b over 2a, and we'll have to figure out what a and b are. The a is everything in this parentheses next to w squared. It's a little bit messy, but it will still give us a number. We'll say negative 1/2 minus 1/4 pi plus 1/8 pi. Our b is slightly more straightforward. That is the number that's next to w. That's 1/2 of p. We can see that our perimeter is given to us as 24 feet. Therefore, we'll say that B is 1/2 of 24, or 12. Therefore, we can say our W will be negative B, that's negative 12, divided by 2 times A. That will be 2 times everything inside of this parentheses, negative 1/2 minus 1/4 pi plus 1/8 pi. We're going to need a calculator to simplify this. This calculation gives us a width of 6.721. Our answer will be in feet. Now that we have our width, we can get the area. We're going to use the area formula that we used at the top of this page. We'll replace all of the W's with 6.721. Therefore, we now have 1/2 perimeter times 6.721. Then we add W squared, that's another 6.721 squared, times everything in the parentheses, that's negative 1/2 minus 1/4 pi plus 1/8 pi. We also know our perimeter is 24, so we can replace the p with 24. Once again, we go to the calculator and enter all of our numbers. This will give us an area of 40.327. The answer will be in feet squared. And so this is how we find the maximum area of this window given that the perimeter is 24 feet.